Hello, this is Section 3, Automated Integration Testing with Ansible. In this section, we'll look at integrating Ansible and Vagrant. We'll talk about using Vagrant to perform some lightweight virtual testing. We'll talk about virtualized test with Ansible and Amazon Web Services. And we'll talk about running tests using Ansible in a Jenkins continuous integration server. Integrating Ansible and Vagrant. In this video, we'll look at building temporary virtual machines using Vagrant. We'll talk about the Vagrant file that will define those machines, and we'll talk about how we can provision our Vagrant virtual machines using Ansible. In our last section, we looked at deploying our application to Amazon Web Services. We looked at a whole deployment architecture. We built a lot of components to do that. Now, some of those components were specific to Amazon Web Services. So the only real way to test them is to actually try a deployment. But many of those components had to do with building up our database server, configuring it, installing our application, and those are all things that we would like to have some kind of test for as part of our DevOps pipeline. Now it's important to notice that that goes beyond just testing our application itself. We're not just running unit tests against our application, though we'll certainly use those. We're also testing the deployment pipeline, the process by which we use Ansible to provision the components of our architecture. In order to test that, because those components run in virtual machines, what we would really like is to have a way to stand up a virtual machine, run tests against it temporarily, and then bring it back down again and not have to worry about it leaving anything behind. That gives us the cleanest possible test of our virtualized environment and our install process using Ansible. And that's exactly where Vagrant comes in. Vagrant is a tool for building, installing onto, provisioning is the term that Vagrant uses, dynamic virtual machines. What we mean by that are virtual machines that are started, they're used for a little while, and then they're torn back down again. Vagrant comes from HashiCorp, the same company that provided Packer. And much like Packer, it's designed to run on top of some existing hypervisor. That could be VirtualBox, it could be Amazon Web Services, and we'll look at both of those examples in this section. What Vagrant does is it starts with a template box. That box is a virtual machine that already has some initial operating system installed, already is ready to run, but it tends to be very minimal. It tends to have only a few packages installed. And then what we do is we use the provisioning process to configure that virtual machine starting from the box in order to do what we need. But the advantage of having in a box-like form is that Vagrant can start up virtual machines very quickly, get them up and running generally in less than a minute. So even in a case with a VirtualBox type environment, if we already start with an existing disk image that has an operating system installed, things go a lot faster. Obviously, in an Amazon Web Services environment, that's the way that Amazon Web Services works already. So what we'll see is that Vagrant just has us specify the Amazon machine image to start from. In order to configure Vagrant, we need to create a Vagrant file. Let's go ahead and take a look at what that looks like. So you can see here, I have a file called Vagrant file. It's in the same directory as the playbooks that we were looking at in section 2, and that'll be important. You'll notice at the top we identify this as Ruby. Vagrant is written in Ruby. The Vagrant file is actually a Ruby file. However, so the syntax of it is Ruby, but Vagrant provides us with a lot of functionality so that all we have to do is set some properties, do a little bit of configuration, and then Vagrant takes it from there. So starting at the top here, you see we define a box, the name of a box, and this is something that Vagrant can actually go out and download for us from the internet. So we start with an existing Ubuntu 16.04 that's already been installed. We can also, right up front here, configure a private network and give it an IP address. And what Vagrant will do is it will add that second network interface using the hypervisor, and then it will actually connect into the virtual machine and configure the virtual machine to use this static IP address. So this is a really convenient thing in that we can add additional network interfaces, even network interfaces with static IP addresses, and Vagrant will automatically configure the VM to have those. You can see we then configure a provider, and you notice that we have the choice to configure multiple providers, and then when we run Vagrant, we'll select which one to use. If we configure VirtualBox, we can set things like memory and CPUs, and there's a number of other options, but those are the only ones that we need. So once we have this box stood up, what we'll have is a temporary virtual machine that Vagrant has created that's based on Ubuntu 16.04. Now, if we want that machine to do something useful, what we need to do is provision it. So if I scroll past this Amazon Web Services section that we'll see in a future video, you can see where I have provisioning steps. I have two steps. In order to get an Ubuntu 16.04 up and running and working correctly, I first do an apt-get update. You can see that just uses the shell provisioner, so it'll just run a command. And then I use the Ansible provisioner. You can see I pass it a playbook file. What's really neat about this is you notice I'm using the same exact playbook file for Vagrant that I also used for Packer. So what I can effectively do here is use this temporary Vagrant virtual machine in order to test all of the work that Packer will do to build the Amazon machine image. What I set in addition to the playbook is I set up the same kind of information that would be in the inventory if I were creating a static inventory file. So the default, the Vagrant virtual machine, if we only define a single virtual machine, it's going to be called default. And so what I want to do is I want to make sure that this default virtual machine ends up in a DB group so that Postgres will be installed, a to-do group so that our to-do application will be installed, and also a test group so that our test scripts will run, and we'll see those in a future video. You notice that just like I can do in the inventory file, I can define variables here, and so I define a variable that tells the to-do app role when it runs in Ansible not to start up the to-do service, because I only want to use this for testing and I don't need the separate service to run. So what I've done here is I've created a Vagrant file. I've told it what box to start from, so what initial configuration. I've told it how to provision that using the shell and then using Ansible. And so the result of this is that when I run a Vagrant up command, it will actually create that virtual machine, it will run the provisioning, and as part of that process, we'll actually run our test. So the outcome of all of this is that we'll actually go through all of the steps that are necessary to install, configure, and then test the software, and we'll be able to determine whether or not the test was successful based on whether this Ansible provisioning succeeds or not. So let's quickly go over and we'll look at a little bit of what that looks like. We won't necessarily wait. It takes about 2 minutes for that whole process to complete, so we won't necessarily wait for that. But if I run Vagrant up here, you can see that because I didn't specify a provider, it's going to default to VirtualBox. It imports this base box, which I already have downloaded and stored locally, and it creates a virtual machine using VirtualBox from this base box. Once that step is finished, it will then go on to attempt to connect to that virtual machine over SSH. So it configures VirtualBox to forward port 22 from the virtual machine to a port that it selects on the host, so that then Vagrant can SSH into that virtual machine. Once it does that, it will then make sure that that host is up and running, and then it will go through the provisioning steps that are necessary. So you can see here, there were no other servers out there using port 2222, so it went ahead and it chose that port on the local host, on the host that's running the virtual machine, in order to connect to the SSH port in the virtual machine itself. So this is the part that takes a little bit of time. So we'll go ahead and leave the example off here. That concludes our look at Vagrant, at how we can provision virtual machines using Ansible, and it finishes our look at the Vagrant file.